Hi, welcome to the video solution for mechanics. This is Edexcel IAL M1 January 2018. So let's start. Question number 1. A particle of weight W is attached at C to two light inextensible string AC and BC. The other ends of the strings are attached to a fixed point A and B on a horizontal ceiling. The particle hangs in equilibrium with the strings in a vertical plane and with AC and AB inclined to the horizontal at 30 and 45 degree respectively, as shown in the figure 1. Find in term of W the tension in the string AC and the tension in BC. Okay, so if you see the diagram, we have a particle of weight W hanging with the help of two ropes. In this case, first you need to visualize the number of forces acting on the particle C. So clearly you can see that you have weight acting downward. This is the weight W, and then you have tension in the string. So because both strings are making different angles, that means tension in both strings must be different. So we say that in string AC we have a tension T1, and let's tension in string BC is T2. So you can say that this is T2. Now we need to find first T1. Tension in string is T1, we need to figure out, and then T2 for BC we need to figure out. This is question mark. Okay, so first we need to resolve T1 and T2 into its component. And how do we do that? We start with the head of a vector, and then so you see that if this angle is 30, then this is alternate angle, this is also 30 degree. That means this component must be equal to T1 sine 30, and this component must be equal to T1 cos 30. Be careful, T1 sine theta is acting upward, and T1 cos 30 is acting leftward. And for T2 we have vertical component like this and the horizontal component like this. So you can say that if this is 45, this angle is also 45, meaning this is opposite component of T2, which is T2 sine 45, and this is horizontal component of T2 cos 45. Now after this, once we have all the components of the forces, remember when we resolve a vector into its component, then the original vectors just gone, because in place of these vectors we have their components. So now I am resolving, or I am looking at forces acting vertical in vertical direction. So vertical forces, I have two vertical forces acting upward, T1 sine 30 and T2 sine 45 acting upward, and the downward force is W. So if I equate vertical forces, I have equation T1 sine 30 plus T2 sine 45. These two are acting upward, equal to downward forces equal to W. So you can simplify more if you wish the same equation after substituting the value of sine 30 using your calculator, or if you know the values in fraction. And so I'm writing the value of sine 30 is 1 upon 2, so T1 1 upon 2 sine 30 plus T2, and sine 45 is under root 2 by 2 equal to W. So this is my equation number 1. Now I'm looking at horizontal forces, resolving forces in horizontal direction. So horizontally I have two forces acting, T1 cos 30 leftward, T2 cos 45 rightward, and because system is in equilibrium, so both forces should be yes, this is an equilibrium, so both forces should be equal. That means T1 cos 30 is equal to T2 cos 45. Moreover, you can substitute, or you can put the value of cos 30 and cos 45 using your calculator in decimal, or it's a good idea to, if you memorize their values. So cos 30 is under root 3 by 2, so T1 is equal to it's T1 into under root 3 by 2, this is cos 30, equal T2 cos 45. Cos 45 is root 2 by 2, and then clearly you can cancel root 2 and root 2 on both sides, so you have root 3 T1 is equal to root 2 T2. This is equation number 2. Now because we have two equations and we have two unknowns, T1 and T2, that's what we need to find in part 1 and 2. So you can solve equation 1 and 2 simultaneously, either by substitution method or elimination method. It's up to you. You can solve and you can find T1 and T2. But in part 1, because we need to find T1, that means I'm using substitution method. From equation number 2, I am finding the value of T2 in terms of T1. So T2 would be equal to under root 3 by root 2 into T1. This is equation number 3. I can substitute the value of T2 in equation number 1 here, and I can figure out value of T1. So putting or substituting value of 3 or equation 3 in 1, so 1 implies that T1, that means this is in fact T1 by 2, so half of T1 plus under root 2 by 2 into T2, and T2 is root 3 by root 2 is equal to W. So root 2 gets cancelled, and clearly you can make T1 as a subject, and if you separate T1, so T1 would be equal to 2W yes 2W divided by 1 plus root 3. So 2W 1 plus root 3, this is the value of T1, your answer of part I. Once you have T1, you can substitute this T1 in equation number 3 to figure out T2. If you substitute T1 here, so you have T2 is equal to root 6 W over 1 plus root 3. This is the value of T2, or tension in string BC. Question number 2. A particle P of weight 40 Newton lies at rest in equilibrium on a fixed rough horizontal surface. A force of magnitude 20 Newton is applied to P. The force acts at an angle theta to the horizontal as shown in the figure 2. The coefficient of friction between P and surface is mu. Given that the particle remains at rest, show that mu is more than or equal to cos theta over 2 plus sine theta. So you need to figure out number of forces acting. First of all, there is a weight acting on the particle, and this is the weight, which is 40 Newton acting vertically down, and we have a contact force acting upward. This is R. The surface is rough, so we have a friction, and friction is always in opposite direction of the motion, and due to 20 Newton the particle is about to move, or is going to move. If the condition is suitable, then the particle is going to move rightward. That means friction would be leftward. So we have these four forces acting on the particle. So R, 40 and F are acting either vertical or horizontal, so we are okay with these, but 20 Newton is making some angle, and if any force makes some angle, the first point is we need to find the vertical and horizontal component of that force. So we need to resolve 20 Newton into its component. So we have a horizontal component and the vertical component. Clearly this is opposite component, that means this is 20 sine theta, and this is 20 cos theta. So we have vertical forces resolving forces in vertical direction. So in vertical direction we have two downward forces, 20 sine theta plus 40 is equal to upward force, and which is only forces R. So equation number 1. And horizontal, we have just two forces. 20 cos theta is acting rightward, so 20 cos theta is equal to friction is acting leftward, so F. So equation number 2. Now there is a key point in this question. Generally, whenever we replace friction with the normal contact force, we have a relation F equal mu R. We generally replace F is equal to mu R, but in this question, instead of F equal to mu R, I am going to replace F with less than and equal to mu R. The simple reason you can say that because you need to show some relation in the form of inequality. That's why instead of equal mu R, I'm going to use inequality. The real reason is we use F equal to mu R if in the question they say that the particle or some object is about to move, and the meaning of this sentence is friction is limiting. Friction is limiting. If friction is limiting, then we have F equal to mu R, but in this case there's no such condition as a limiting friction. That's why we need to use F is less than and equal to mu R. So equation 2 becomes 20 cos theta is less than and equal to mu R. And now you can replace this R from equation number 1. So you say that 20 cos theta is less than and equal to mu times of R, and R is in equation number 1 20 sine theta plus 40. So 20 sine theta plus 40, and then you can take 20 common. So 20 cos theta is less than and equal to 20 mu. It's a sine theta plus 2, and then 20 and 20 gets cancelled. So mu sine 2 plus sine theta is more than and equal to cos theta, and then mu is more than and equal to cos theta divided by 2 plus sine theta. This is your proof. Question number 3. Two particles A and B have masses 2m and km respectively. The particles are moving in opposite direction along the same straight smooth horizontal line, so that particles collide directly immediately before collision. A has speed 2u and B has speed u. The direction of motion of each particle is reversed by the collision. Immediately after the collision, the speed of A is u by 2. Find in terms of m and u the magnitude of impulse exerted by B on A. So here is the situation. You have particle A of mass 2m and moving, let's say, rightward. So its velocity is 2u. This is particle A, and particle B with mass km moving left with the speed initial u. Okay, and then they collide, and after collision, so motion of each particle is reversed. This is important. So both particles after collision now are moving in opposite direction, and the speed after collision, speed of A after collision is u by 2. So this is minus u by 2. Remember, I generally use rightward direction positive and leftward direction negative, and it's your choice. You can choose otherwise, so it's fine. So this is minus u by 2, and final velocity of particle B is not given, so I'm assuming this is v. So this also, initial velocity is not u, it is minus u. We need to find impulse on A by B. So impulse I is change in momentum, delta p, or because we need to find impulse on A, delta p of A. That means I is equal to mass into change in velocity of A, delta VA. So mass is mass of the particle A, and mass of the particle A is 2m. So this is 2m into change in velocity, final minus initial. So the final velocity is minus u by 2 minus initial velocity, and initial velocity is 2u. If you solve this, so this is 2m, so minus u minus 4u minus 5u by 2. So 2 gets cancelled. So I is equal to minus 5 mu, because you need magnitude only. So I is 5 mu. This is impulse on A by B. Okay, so part B, show that K is less than and equal to 5. Okay, so we need, again, because we need to apply law of conservation of momentum. This is the situation. Particle A moving right with velocity 2u, particle B leftward with velocity minus u. Remember, this is the mass 2m, this is the mass km. We have a collision, directions of both particles are reversed, so minus u by 2 and then v. So we can apply law of conservation of momentum. So conservation law of momentum, or you can say law of conservation of momentum, but it's confused. You someone might think that is LCM. It's not LCM, it's law of conservation of momentum. I guess you're okay. So now momentum before is equal to momentum after. So momentum before is equal to momentum after. So you can say that before you have total momentum 2m times 2u and minus km into u. This minus I'm using because of the direction of particle B, is equal to momentum after is 2m minus u by 2, yes, minus u by 2 and km v. So you can say that this is 4mu minus kmu. 2 gets cancelled and you have minus mu plus kmv. So because we don't know the value of v, so we cannot figure out the value of k, but we have one mathematical concept according to the diagram. As particle B is moving rightward, so as per our condition, so I can rearrange this equation as, if I send minus mu on the other side, so I have kmv is equal to 5 mu minus kmu. Okay, and then if I take mu common, so I have 5 minus k. This is kmv. Now if you see that since v should be positive, what is the meaning of this? Because in my assumption, particle B after collision is moving rightward. That means the velocity of particle B should be positive, and it will be positive if and only if and only if and only if 5 minus k is positive. That means 5 minus k should be positive. That means minus k should be more than minus 5, or if you multiply with the minus 1, the whole inequality, so k, then the sign of inequality is reverse, k is less than 5. Make sure that you understand this relation, because this is the equation and left hand side of the equation is positive. It has to be positive because of v, and v depends on this factor. So if k is less than 5, then whole factor will be negative, so v will be negative, which is against the condition. I hope you understood. Question number 4. A package of mass 6 kg is held at rest at a fixed point A on a rough plane. The plane is inclined 30 degrees to the horizontal. The package is released from rest and slide down a line of greatest slope of the plane. The coefficient of friction between the package and the plane is 1/4. The package is modeled as particle. Find the magnitude of acceleration of package. So you have an inclined plane making angle 30 degrees, and at some point you have a package which is released and the package is moving down. So this is an inclined plane case. So you have a weight acting down, mass is 6 kg, that means this is 6g. You have a reaction, normal contact force, and then it is sliding down, so you have friction in that direction. So overall, these three forces are acting on this particle. But you know that you can resolve 6g into its component. So you have 6g sine 30 and you have 6g cos 30. So this is 6g sine 30 and this is 6g cos 30. Remember, after resolving forces, the original force gone. So now you can write system of equation because we have resolved forces. So we have vertical forces or vertical to the plane, perpendicular to the plane. We have forces which are 6g cos 30 is equal to r, and then you can substitute cos 30 value. So 6g is cos 30 is under root 3 upon 2 is equal to r. 2 and 3 cancel, so this is 3 root 3 g is equal to r. This is your first equation. Now look at forces parallel to the plane. Parallel to the plane. In parallel to the plane, we have two forces acting. 6g sine 30 acting downward, down the plane, f up the plane. So you can say that you have and it is sliding down. That means 6g sine 30. 6g sine 30 is greater than friction. That's why it is sliding down, and that's meaning of this is you have a net force. You have net force. So that means 6g sine 30 minus f is equal to ma, and ma is 6a. So you can replace f with the mu r and sine 30 its value. So 6g into sine 30. Sine 30 is 1 upon 2 minus f. F is mu r is equal to 6a. So 3 and 6 gone. So you have 2g minus mu r is equal to 3 this is not 1 upon 3 because I saw that this is 1 upon 2. Sine 30 is 1 upon 2. So 2 and then 3. So this must be 3g. 3g minus mu r is equal to 6a. Okay, this is your equation number 2. So you have two equations. Equation 1 is 3 root 3g is equal to r, and equation 2 is 3g minus mu r is equal to 6a. you need to figure out acceleration. So you can solve these two equations simultaneously to find A, and the easiest method is you can multiply the equation 1 with mu, and then you can subtract the value. So what I'm doing here, I'm multiplying 1 by mu. So if you multiply 1 by mu is 3 root 3g into mu minus mu r. I'm sending r on the other side so I can subtract easily after sending r, and then I'm multiplying by mu. So minus mu r is equal to 0, and then I'm going to subtract this equation from 2, or two equation or subtracting 2 from 1, whatever suits you. So I'm writing equation 2 underneath. This is 3g minus mu r is equal to 6a. Subtracting means need to change the sign of lower equation. That means this is minus 6a plus mu r and minus 3g. So finally you have mu r gets cancelled. So 3 root 3 g mu minus 3g is equal to minus 6a. Now you have everything. G is 9.8, mu is 0.25, that is quarter, and you can figure out A. So if you send minus 6 on the other side and you substitute all the values, so A would be equal to 2.78 meter second minus 2. This is the acceleration. As it slides down the slope, the package passes through the point B where AB is 10 meter. Find the speed of the package as it is passing through the B. It's a straightforward question. So you have inclined plane, particle A, from where you just release a particle and it is sliding down. There is some point B. When it is passing B, it has some velocity. Of course, you need to figure out that velocity. So, and the distance between A and B is given, which is 10 meter. So you have given a distance. You need to find final velocity, initial velocity as it is releasing from rest. So initial velocity is 0. Clearly, you need to use third equation of motion. V squared is equal to u squared plus 2as. So V squared is equal to 0 plus 2 times of 2.78 times 10. You can multiply these and take the square root. So V would be equal to 7.45 meter second minus 1. Thank you very much for this video. Have a nice time.